Hello. Hi guys, good morning. Welcome back to the new video. It's no problem. Smallest missing integer greater than sequential prefix sum. Although being easy, but the statement is very complicated. The statement, I'll just simplify that and tell you. What it says is we are given an array of nums. Okay, you can see we have an array of nums. Now, basically a prefix is something which starts from the very beginning. Again, a prefix which is starting from the very beginning is sequential. It is sequential if I am having something as nums of j is nums of j minus 1 plus 1. So basically from the very starting itself, it should be increasing in 1 plus 1 plus 1 plus 1. Okay, and it also says that nums of 0 also just one element is itself sequential, so that is not a worry for us. Okay, one element is also sequential in this. If you will see, starting off from the very start, okay, I'll just increase up till here it will end. So, and again it needs to expect a 4, but the 4 is not there, so the sequence will stop up till 3. So the sequence is 1 2 3. Now it says we have to return the smallest integer x missing from nums such that x is greater than or equal to the sum of the longest sequential prefix. So longest sequential prefix, because you saw that you tried to go as far as possible but you could not go any further, so longest sequential prefix is 1 2 3. The sum of that longest sequential prefix will be a 6. Now you have to find the smallest number which is greater than or equal to this number, which is the sequential prefix sum, and it should not be inside this array. So you will start off to check, okay, 6 is 6 inside my array? No, it is not. Yeah, so answer is my 6. It's the smallest number, so that's the thing. You return a 6. Again, that's it. It's a bit complicated statement. So again, we will start off to find the sequential prefix. Okay, sequential prefix. I want the longest sequential prefix, so okay, I'll just keep on going. Oh, I cannot go any further. Okay, so my longest sequential prefix is a 3 4 and 5. The sum for it is simply a 12. Now I want to find the smallest number that, okay, it should be greater than or equal to 12. Okay, and it should not be inside my nums array. 12 is inside my nums array. Yeah, it is. Okay, let's try for 13. 13 also inside my nums array. Okay, let's try for 14. 14 also inside. Okay, let's try for 15. 15, oh, it's not inside. So answer is 15. So I'll replicate the same stuff. First I will find the longest sequential prefix, then I'll parallelly take the sum of that longest sequential prefix, and then I will just say this sum which I have obtained, which is 12 in this case, I will just try, okay, see, is that in my nums vector or nums array? Is that in my nums array? If yes, then I have to increase my sum, do a sum plus 1, and again check in my nums vector, until I find any element which is not in my nums vector, that is the smallest element, and that I will simply return. That is the reason how you can solve it. Again, if you go into the code, it's pretty simple. Again, by using STL, you can also modularize, as in make this code a bit shorter. How you can do that? Firstly, you got the initial sum value as I told you also. One element is also sequential, right? So one element is itself a prefix. It's a longest sequential prefix, right? So okay, sum can be nums of 0. Then I have this n initialized. Now I have this unordered set. Just saying that why this unordered set is needed, because you remembered, right? Although you will find your longest sequential prefix, but then you will have to find in the entire vector if that is present or not. If that is present, then you have to increase your sum. Keep on increasing the sum until it is present. So to find out in the vector takes a O of n time to find. You can use a set, unordered set, to find. So that's the reason. So the only reason I use unordered set is so that it can be used for future to find my sum. Now this portion of code is just finding the longest prefix, sequential prefix sum. So it just check, okay, the sequential condition is valid or not. If this is valid, then I can simply increase in my sum, I can simply add in my sum. If not, then simply break, because I want sequential prefix sum. As soon as it breaks, simply break my sum also. Now I can simply go on and simply ask, okay, until this sum is present in my set, which means, and this set is made up of my nums, basically this vector which I have. If it is present in my set, bro, keep on increasing my sum. If it is not present in my set, then it will break, and you can simply return the sum, which is your answer, which is your smallest integer x which is missing from your num such that x is greater than or equal to the sum of the longest sequential prefix. Although the question marked as easy, but it is a bit tricky to understand the statement itself, the first page. I hope that you got it. Bye bye.